The first part of this question is relatively straightforward, provided we read the question carefully. There are 3 prizes, one for English, one for French and one for Spanish, which are to be awarded in a class of 20 students. Find the number of ways in which the 3 prizes can be awarded if, in the first part, no student may win more than 1 prize. So in this situation, the order matters because there are prizes for 3 different subjects. If all the 3 prizes were the same, we'd be looking simply at 20C3, the number of ways of choosing the 3 students that get prizes out of the 20 students. But that's not the case here. There's 3 different prizes, so if we gave the English prize to the first student, the French prize to the second student, and the Spanish prize to the third student, that would be a different situation from, say, giving the French prize to the first student, Spanish to the second student, and English to the third, and so on. So in this case, arrangements of the students are going to matter, and this is where we use NPR. This gives the number of ways of arranging R things chosen from N things. So we want to look at the number of ways of arranging the 3 prizes chosen from the 20 students. So we can use the NPR button on a calculator. That's 20, shift, and then the button with NPR, and then 3, which we can see gives us a value of 6,840. The question wasn't asking for a probability, so we're not looking for a value between 0 and 1. 6,840 is the number of ways of giving out those 3 prizes. Now, one other way of looking at this, which is actually quite helpful, is to think about allocating the prizes as we go along. So we've got the 3 prizes. We could choose any of the 20 students to get the English prize, but once that's been allocated, then that student cannot also get the French prize, so there are only 19 students left to choose from. And similarly, then we've only got 18 students left to choose from for who gets the Spanish prize. And 20 multiplied by 19 multiplied by 18 gives us exactly the same results as before. The second part of this question is easy once you know how, but quite difficult if you don't spot the easy way to do it. So in this case, no student may win all 3 prizes. It turns out the easiest way is to consider the situations, all of the situations that are possible, including having students winning all 3 prizes, and then subtract the situations where a student wins all 3 prizes. So we're looking at the number of ways where students can win any number of prizes, and we're going to subtract the number of ways where one student wins all 3 prizes. So the first part, we could be picturing the ways to allocate the prizes. Because any student can have any number of prizes, we've got 20 students who could each win English and French and Spanish. So 20 multiplied by 20 multiplied by 20. That's 8,000 ways to allocate the prizes. But we're not allowed to include the ways where one student wins all 3 prizes. Well, there are 20 students, so there's 20 choices of which student wins all 3 prizes. So our final answer is just 20 cubed minus 20, giving us 7,980 ways of awarding the prizes. One of the most common wrong answers was to use 20 multiplied by 20 multiplied by 19. You might think that this would be sensible because there are 20 students who could win the first prize, 20 students who could win the second prize, and then you're only allowed to win at most 2 prizes, so that leaves us with 19 students who could win the third prize. This sort of approach can be used successfully, but it's much more difficult because we need to think a bit more carefully than that. We'd still have the first possibility of all 3 prizes going to 3 different students, like in part 1 of the question, 20 multiplied by 19 multiplied by 18. But then, we could give the English and the French both to one student and the Spanish to another student. So we could say there's 20 ways of choosing who gets the English and French and 19 ways of choosing who gets the Spanish prize. But then we'd need to look at the other combinations that are possible. It could be that one student gets the French and Spanish prize and then the English would have to go to someone else, or one student gets the English and the Spanish and then the French would have to go to someone else. If we put all of these situations together, they do indeed give us the total of 7,980, which is the same as working out by the other method. The mark scheme doesn't reveal very much here. It makes it look very straightforward. However, in the examiner's comments, it was revealed that very few students managed to score all 4 marks on this question.